let's jump into Python inheritance. So let me get on. Oh shit. Can everyone hear me? Can everyone hear me? Sorry.
We lost you for a minute, but now you're back.
Okay, cool. Sorry about that. Internet's still wanky. Okay. So let's talk about Python inheritance. We kind of covered it a little bit in School Interface 1. But when you think about inheriting something, what do you think about when you think about the word inheritance? Anybody?
When you're given something by default, or when you're given something like initially without your input.
Right. Exactly. So if you think about inheriting, if you have parents, obviously everyone has parents. If you inherit something from your biological mother or father, you inherit specific traits from your parent. So when you're inheriting things, traits are passed down. You can never pass a trait up. Like I can never pass like my pale skin to my dad because my dad's Italian and he's like super dark. So like I can't pass my skin color to my dad. Likewise with eye color, you can't pass traits upwards. You can only inherit things that they're passed downwards. So in Python when you're using inheritance in Python, you can inherit traits from a parent, but you can't manipulate those specific traits on that parent. So for example, like if your parent has a specific eye color, you may or may not inherit, you can like by default inherit their eye color, but you might have a slightly different shade of eye color or something like that. So with that, let's talk about and why we use Python inheritance. So for example, let's create a file called dog.py and code dog.py. So we're going to create a class dog class. Let's move that over here. Class dog. And each dog is initialized, let's say, with a name. So self.name equals name. And then what are some things that, dogs like to do? What are some things dogs do? What are some actions that dogs like to do?
Sleep.
Okay, so we can create a method that says sleep self, and it can like return I'm sleeping, don't bother me. What else do dogs do?
Eat.
Yep, thank you. So like return I love kibble. Dogs also, like to play fetch, or at least some of them do. Return, throw the frisbee. And you can say like def, bark, yep, bark, self. And it just says return, woof, woof. Cool, here are just some attributes about a dog. So I can create a new dog, like Fido equals dog, I'm passing in Fido. I can do Fido dot name. And I can do Fido.name, it's instance variable. I can then eat, fetch, bark, etc. And sleep, I guess. If I run all those, like Fido, my name is Fido, I love kibble, throw the frisbee, woof woof, I'm sleeping, don't bother me. So that's like the basic dog class. But we can get to a little more granular where we have different types of dogs. So we have an initial dog class, but now we can create, so from a dog, but what kind of different dogs can we have? We can have Labs, Bernese, Maltese, you know, all kinds of different dogs, Pyrenees, you know. So we can actually create more classes from dog. So I'm going to create a couple of files, touch, Labra, py, and Maltese, .py. I'm going to code Labrador and Maltese. I'm going to split the dog over here because that's the main class. So now we have a dog that has a name and just some basic attributes that they do. They sleep, they eat, they fetch, they bark. But we can get a little more granular than that. We can actually create a class of dog, but a little more, I don't even know if that's how you spell Labrador. Labrador. And the Labrador class can inherit all the attributes from a dog. So sleeps, eats, they fetch, and they bark. So I can say like from dog import dog. And now I can inside my init method, I need to take in the name of the dog. I can also take in, let's take in the size of the Labrador. So right now in the dog class, I only want to take in the name, but in the Labrador, I want to take in the size and the color of the lab. So instead of doing like self.name again, I want to inherit the name method, the name instance variable from the dog class. We kind of covered it in school interface 1, but how do I access the init method from the dog class? Or how do I, the name, the instance variable from the dog class?
Super.
Yep, I can call super, which says, hey, whatever the parent class is, execute the init, and then we pass in the name, and now I can do self.size equals size, and self.color equals color. So I can even do like self.likes, I don't know, like swimming equals false. Swimming as a default, just say false. Simming. So just to make it a little more granular. So again, you can inherit attributes from your parent, but like you can get a little more specific, like because your parent dog is pretty generic, but as you get more granular, you might want a little more explicit attributes that like define this specific class Labrador a little bit more. So in here, if I create a new lab and I pass in Labrador and pass in my first dog, Sadie. Sadie was a big dog, and what was chocolate and swimming. Yeah, she liked to swim. So if I can print new lab, like name, size, color, likes swimming, and I run that, clear, Python, Labrador, Sadie, it's a big dog, chocolate, color's true. But Sadie is still a dog, or this Labrador is still a dog. So the new dog or the new lab still can bark, still has access to these instance methods because I inherit them from the dog class into the Labrador class. So I still have access to all these instance methods. So I can do like sleep, new lab dot sleep. If I execute that, I'm sleeping, don't bother me. So I have access to that. So all these different methods from the parent class down to the dog class.
So
But what?
Tom,
Yep.
if you wanted to say, so for sleep, if you wanted it to return, Sadie says, I'm sleeping, don't bother me. Is that an example of how you can't inherit things upstream?
Yep.
So like, could you put string interpolation, dog name, new lab name or something there, or would it get confused?
So yeah, I kind of want to show you exactly. That's exactly where I was going. So you can inherit the sleep method, but just like if your parents have blue eyes or brown eyes, you can inherit like a mixture of blue and brown eyes. I don't know if that's actually true, if it's like a mixture, but like your skin color might be a little, like my mom's Irish, my dad's Italian, my dad's pretty dark, my mom's pale, and like they can get to like my brother, he's like he's not as fair as me, but like he's kind of tanned, he's like average. So we can get into like, you can like overwrite specific attributes that you inherit. So I can do like def sleep self and say like return f string sleeping is okay, but I'd rather be swimming or something. So if instead of new lab sleep saying is I'm sleeping, don't bother me, and say sleeping is okay, but I'd rather be sleeping. Same with like def bark self. Since this is a big dog, I can like return I'm self dot size bark, and now I can do bark. Whoop. What did I do?
Format string.
You need your F.
Oh, F string. Thank you. I was wondering why that wasn't changing color.
So basically what you've done here is you've overwritten your inherited traits of sleep and bark.
Correct.
Okay. And is there any way to combine, to take in that the blue eyes that you got from your parents and then like make them a little bit darker blue? Or do you have to just start with a new color every time? if you don't want the exact same thing your parents had.
I don't know if there's a way to grab the dog class's value and like method and manipulate it in a way and combine it with a new method. Is that kind of what you're asking?
Yeah, I guess so.
Yeah, I don't think if there is a way, I've never seen it before, and I don't know if that's best practice to do. So like essentially like adding on additional attributes from the bark or some from the parents.
Yeah,
Instance
I guess
method.
so. Yeah, if you wanted to cap, if all dogs say "I'm sleeping, don't bother me" when they are sleeping, then maybe you want to add on their name at the beginning or something like that, so you know who's talking. I don't know.
So like, yeah, let's see if there is a way to do that. I don't think there might be.
Could you return name, F string, new lab name or self.name, and then plus or whatever import that previous the thing
Dog
dogs say.
Sleep. I don't know if that's possible.
Okay.
I'm just messing around now. So, don't bother me. Go away. Don't. I'm sleeping. Don't bother me. And then just let's just whatever self dot size or something.
Yeah.
Now yeah. Yeah, I don't think so.
Okay, thanks.
Yeah. So the point of inheritance is you can inherit all the instance methods and the instance variables, and I guess the class variables as well, into the Labrador class. So you have access to the name and everything from the Labrador class. But you can also have specific attributes that are explicit to the Labrador class that don't exist in the dog class. And you can't pass these color or like swimming up to the dog class because inheritance only goes down from parent to child. And likewise, you can also overwrite methods that you inherit from your parent. But you can also have your own methods. Print name or print something that says like what color am I? And it's just like return self.color. So I have overwritten sleep, bark, and I'm having its own unique method. What color am I? So you can overwrite methods from your parent or just utilize or just use your whatever methods that you want from your parent, or you can overwrite them, or you can just declare new methods that don't exist, that you don't inherit.
I have a question, Tom.
Yep.
Can you explain to me with the super method how we pass the argument name to the right of init? What does that mean?
Right, this thing.
Yep, but also name to the right of init.
So init, I'm literally just passing in the name Sadie, comes into the init method, and I'm passing the name into the init method, which is invoking the init method from my parent, denoted by the super. So super just looks at your whatever looks at your parent class, and now it passes the name into this init method in the dog class, which is my parent. So that's what's happening on line 6.
So super knows to look at the parent?
Yep, exactly.
Okay.
Can you scroll down a little bit for me, Tom? Thank you.
So if you want to think about it, you can also do like dog, Labrador, employee. You can break it down in employee to like a very specific job title, like employee. It has like specific attributes like name, a like name, ID number, and then you can inherit other stuff from employee. So like a developer or like a marketing person or a manager can inherit from an employee class. So you can keep going. There's a bunch of different ways, just like we did from person and is a parent of a student, also is a parent of a staff, because like a person is pretty generic.
So is it pretty common to create a parent and never actually ever use the parent and only use the children?
Yeah. Like as in like calling the children, because you're still utilizing the parent by.
Oh yeah, specifically like calling a method from, you'd never call a method from dog, for example, you always call it through Labrador.
So I create a method dog, or like I'm invoking a new lab class, but I'm utilizing a method from dog. So yeah, so I'm sorry, is your question is
Oh, so it would still, you would still technically be using a dog method. It doesn't like copy them over. It just tells you to look here instead.
yep, exactly. So if we look at, let's go. Oh, shoot. I don't know what I just did. Let's go back. Oh, what did I do? Nope. Do I have any? TDD. I'm looking for something real quick. Where is it? Crikey's. Okay. So example, we've been utilizing parents. So here's the validate phone number challenge that we did, and we wrote some unit tests for it. So in here, so when we've been writing unit tests for Python, we've been in here, we imported the unit test library from Python, and we're inheriting that from the test case class, and we're passing it in to the validate phone test case. And now we actually have available the self.true, self.false. All these are instance methods from this test case parent class.
So in that case, a unit test is the name of the actual file then?
Unit test is like the name of the library.
Okay, so it's another thing within the file? Like how do they define that name unit test? Is that like unit test.py and then in unit test.py is the test case class?
No, so unit test is the module or library, and then to access all the objects or classes off of the unit test library, we can call whatever class we want. I don't know if that answered your question.
So the library is made up of a bunch of different Python files, basically?
Yep.
So unit test is like a folder or directory?
Yeah, but it's actually like, if you want to think of it like that, you can, but it's actually like a module. It's like it's a huge, a bunch of files, folders, directory, and code written. But yeah.
Package.
Yeah, it's a package or module or library. They're all, those terms are all used. Yeah.
Can a what do you call them, child class inherit from more than one parent?
No, but you can like have a parent or a child inheriting from a parent, and then have that parent inheriting from another parent. So like a grandmother or grandfather.
So you can chain them
Yeah.
if you need it. Okay.
Yeah. And you'll see this more when we get to Django. So yeah, so see, it says like the class test case is a class whose instance are single test, blah, 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 and it has a bunch of attributes on it. And this validate phone test cases is inheriting all the attributes from the test case class. And we can even do import test case and get rid of that test case. And it should still work. So we're just importing this object or this class from the unit test library.
Do class variables and class methods also transfer over from the parent?
Yep.
So would you be able to access all dog, like from your Labrador thing, would you be able to access all dogs, even other dogs that aren't Labradors, from a class variable in dog?
Hold on a second. Say it one more time.
So if you have multiple children using parent class, in this example, it was dog. But say you had like a class variable that tracked all the dogs or something that were created with dog.
Oh yeah. So like all dogs.
And you'd be able to access that from the Labrador
Yep. So it's
child.
yeah, you should be able to. I believe so. Let's check it out. What did I just do? Okay. Python. Yeah. So in here, when we create a new dog, we can say like dog.all dogs plus. There, now we got one. So yeah. So if I run this again, now it's 2. So yeah, you can. Any other questions?
Hey Tom, can we go back and try the parent method thing that we were trying with Augie's question from earlier? Because it looked like it might have worked if you'd passed self inside the call.
So like self.bark, or what is it, sleep? So in the call, oh, I see. So if I do dog.sleep and pass in self plus self.size, just for all intensive purposes. And then if I call sleep, I don't know of a case where this would be actually, yeah, plus big. Oh, I do plus. Yeah. So that's one way you can do it. But I don't know if I've ever seen a case where you would, like an actual reason why we would do that. But yeah, it's good to know that you can do that. All right. I'm gonna